Hi, my name is Joanna Sendorek and I'm a software engineer at VirtusLab.
Hello, my name is Zbyszek Królikowski and I am a software engineer at VirtusLab. Today we'll talk about the pandas-stubs library. We will also show you how to create your own stubs library. So let's start off with the Python type system. As you probably are aware, Python uses a dynamic type system which is processed during the interpreter runtime. The drawback of this approach is that before your code is executed, you have to make assumptions about types of objects. This in turn increases the amount of testing you have to make to ensure your code works according to this assumed interface. PEP 484 introduces static typing, which is optional and external to the interpreter. So how can you add type information to your code? There are two methods. The first one is by using type annotations, and the other is stub files. On the top, you can see how to use annotations, and on the bottom, how to use stubs. You can think of stubs as header files from C or interfaces found in object-oriented programming languages like Java.
Okay, so we would like to demonstrate the pandas-stubs package, which is available both for pip and conda forge. Pandas-stubs, so the library, enriches pandas installation with type information, and it enables type checking by tools like Mypy or Pyrite. Let's see the simple case when this can be useful. So here we have an example of smart backfill method, which under some condition calls method fillNa, which is filling the non-values in the pandas API, and it either fills it correctly or incorrectly, dependent on the condition in the if closure. In order to test this method, the unit test has been written. But it only tests one branch of conditional statement, the correct one. So as expected, the test passes and without additional checks, and we will never know if the branch is correct. So we will never really see the error, which is in the last line with backfill. So obviously, proper tests should cover all of those cases, but sometimes the unit test tends to be imperfect, and we want some static method to make sure that we can detect this error even before any code is executed. So let's see what we can do, what happens when we install pandas-stubs package and run Mypy static checks for the given piece of code. We will get immediate error saying that the string value back_fill is not proper, and we will also get the list of all of the correct values that we can use instead. This way we can prevent incorrect API calls even without running the actual code, as happens in the unit tests. Okay, and speaking of, we'll show you the next example.
Yeah, so this is a real-world example. This is a repository containing a bunch of Python code. So let's start off with just vanilla Mypy. And what you can see immediately after using Mypy on this code is that we get a bunch of errors saying that pandas has no type information and what do you want me to do? So we can prevent this from happening by silencing this issue by correct Mypy configuration, which prevents Mypy from reporting any issues related to the pandas library. So that's a setup you might use in your project if you use Mypy for general use. However, you don't want to get any pandas issues. So let's look at the errors that we get by just running Mypy after setting it up correctly. So we have a bunch of issues, and actually all of them are false positives. So Mypy doesn't always work well. I haven't looked why this happened in this example, but overall, if you look at the amount of errors in this repository, which is a few dozen source files long, it looks like this. It's okay. Like we don't have any more like a lot of issues. It must be type safe. Type safe. So, but if we install pandas-stubs, another thing, like completely, we get a completely different image. So here's how what happens after we've installed it, and as you can see, we have a bunch of errors, which are actually related to pandas. So you get that benefit, and actually some of those errors are false positives, so work in progress. Some are a rather unsafe operation, which aren't compatible with the type system. But like you get at least you know what's happening in your project. At least you know that you have some issues. And before installing pandas-stubs, you had no knowledge of it altogether. So what does happen when you install pandas-stubs? So the existing Python files stay in place, uh, like they they just stay the same as they were, and the stub files from the new library are with the same set of names are placed alongside them. As you can see, they are denoted by the PYI extension. And what happens when Mypy wants to retrieve type information for pandas? It first looks at the stub files, and then if they are not available, it will only then look at the Python files. Okay, so how can we start off with generating this kind of type stubs? So the good place to start is by using the type stubs, which can be generated by a program like stubgen, which is bundled with Mypy, or by using Pyrite. Here's an example output of running stubgen for a library called language segmentation. As you can see, it looks like a regular Python class, however, with all the implementations of attributes just filled up by the ellipsis symbol.
Okay, so now we can know that we can generate the stubs and method signatures with the external tools. And on the previous slide, we saw some correct annotations. But how can be sure that the annotations are not only correct, but also precise? So here we can see an example of the generated stub for dot method, which is part of the data frame API in Pandas. And we can see that it accepts the union of frame or series or error-like argument, and then it returns frame or series. So this is the correct stub. It covers all kinds of AP calls, the correct ones that we can do with Pandas. But is it really precise? So we can take a look at the documentation. And in the documentation, we can see that we know the specific times when we will either return data frame or series. We can know it beforehand. It's not like for the series, we can get the data frame or other ways around. So we can include this information in the stub by doing the overload of annotations for dot method. So on the on the bottom one piece of code, we can see 3 parallel definitions for dot method, and each of them has different signature. It's a little bit different, but we can see that together they're like the annotation on the top one piece of code. Just this time, this is more precise because we can, for example, detect the times when we pass the series to the method, but we are expecting the data frame, which is incorrect according to the documentation. So we can not only make our stubs correct by using some generator, but we can also make them more precise by individually looking at the API and documentation together. So now let's see how we can test the stubs and what does it mean for the stubs to be correct. So you may wonder, how do we assert that the stubs we implement or modify are proper ones? First of all, we might want to check internal consistency, which means that running Mypy checks on the stubs themselves is not showing any errors. This way we can detect missing annotations, incorrect types when overriding methods, or for example, improper usages of generic types. Apart from this, so from checking the stubs with the type checkers, we can also check, or rather it should be our primary goal, to ensure that the API calls that we are doing with our stubs library are correctly recognized by the Mypy or other static checker. For example, imagine a situation when we are notified about the issue in our library and we fix it. So how do we know that by doing the changes we are not introducing another bug? So how do we know that by making the new change we are not breaking something that was working previously? In pandas-stubs, we are ensuring it by adding test snippets with the real API calls as part of our CI process. So each time we are doing any change in the code, we know that we don't have to deal with the regression bugs. And this way we know that we are only improving the library, not going backwards. And on the slide you can see the example test snippet, which just consists of multiple calls of a group by method, which is part of the data frame API. And we use sort of different argument types and values to make sure that we are covering as much as possible. And then we can see that by running PyTest on the test snippets, we are making sure it's working, but also by running the Mypy on the test snippets, we can make sure that we are covering all of the API calls and they are correct. Okay, so now let's move on to talking more about our library and how it is used currently. So here is a chart which shows the current usage by the number of daily downloads. In total, we observe around 140,000 of downloads per month. But it's different from a day to day, and you can definitely see some tendencies here. And it's rather cyclic, the number of downloads. So looking at the chart, you can also see very high peak around 10th September, and wonder what caused such difference. At least that's what we were wondering about when we saw it. So we discovered after some small research that around this date, one of the biggest Python projects, which is OpenAI Python, started using our library as one of the dependencies. So yeah, we were really excited about. I think we are really happy that our library proves to be useful not only for smaller projects, but also for some greater ones. And it can be a dependency along with some known libraries like requests, for example, or pandas itself.
Yeah, so let's talk about the plans on improving the stubs. So first of all, we are concentrating on the API. So pandas internals themselves are relatively well covered by annotations by the pandas development team and open source contributors. So there's not much point in going through pandas internals and trying to fix the annotations within, because it's already tested, it's already being done. So, and that's the reason why we are only concerned with the API. So interfaces like data frame API, series API, indexes, string methods, and so on. And so we have a pretty good coverage right now. We cover most of the major classes. However, we don't we haven't finished our work. There is still a lot of to do, a lot of signatures to match, a lot of tests to fix, and there's still a lot of work to be done. And as I said, our test snippets, they don't cover every declaration possible. We have plans to extend them as widely as possible. The Pandas API is so broad, itself is so broad that it's difficult to find all of those problems beforehand, and it's often the case that people are creating issues on our GitHub repository about some unusual case they just encountered and they want us to fix it, or they have a proposition to fix and we just have to implement it. And this is all good. We still have future plans. We can develop pandas-stubs for months and months. However, there is a parallel plan we have for pandas-stubs. And let me talk a bit about that. So we have been in talk with the Pandas core development team about using what our work and work of our contributors to improve pandas themselves. It's fair to say that pandas-stubs isn't the only effort in this area. Microsoft has been releasing type stubs for a lot of Python projects which are used for auto-completion in Visual Studio Code. We have attached the link, and they are pretty good as well. We don't see them as competitors, that's also the reason why together with Microsoft and the Pandas team, we made some plans to include both our work and Microsoft's work into Pandas itself by using most of the, if not all of the Microsoft type stubs, perhaps with fixes from our side, we'll see, and all of our testing we are doing on the stubs themselves, so all of our snippets tests, and that's an ongoing issue, and we'll be doing some steps in that area. However, this will probably take months, if not, hopefully not months, but it might take a while. And pandas will probably not ship with type information immediately. Currently, if you install pandas, you don't include any type information. It's being scrapped from the package before sending it over to PyPy and CondaForge. And so it might take a while before that happens. Until then, we'll continue to develop our stubs, and also make any contribute to pandas itself with any new features and fixes.
Yeah, so from this moment, we would like to say thanks to people who also helped us very much with setting up the project and the initial work that we had to do. So thanks to Paweł Lipski for setting up the repository and the initial CAI. This really is going much more smoothly now. And also to Hubert Pomorski for adding CondaForge support. Which was also like one of the main things that we needed to start off with the project on like in a serious way. So here is the link also to our project and some follow-up reading to the blog post, the link to the blog post that we created together with Zbigniew some months ago at the VirtusLab blog post site. So thanks again. And thank you to all of the listeners, and we are really happy to have you here, and we are welcome to the questions that may arise.
Thank you.
Thank you.